Okay, this is going to be my first of many videos talking about AP Calculus AB. This is a full comprehensive review of, everything that's going to be on that test. So, follow along. I would recommend taking notes if there's something that you just don't remember at all. And yeah, let's just get right into it, starting with Unit 1. So, average rate of change. Pretty simple. You probably remember this from pre-calculus. It's y1 minus y2 over x1 minus x2. It's basically just finding the slope between 2 points. Next is limit notation. It's done like this. And what this basically is saying is as x approaches a, f of x approaches L. And if the limit of f of x as it approaches a from the left is equal to the limit of f of x as it approaches the right, that means that the limit of f of x as it approaches a in general is equal to L. And then this right here is basically just talking about the arithmetic that might come with limit notation. For example, let's say you're trying to find the limit of f of x squared over gx minus x squared plus 5. And you know that limit of f of x is equal to 5 and the limit of g of x is equal to 4 as it approaches 3. So you would separate these into like some separate limit notations. This is the limit of f of x as it approaches x to the limit of f of x as x approaches 3 squared times or divided by the limit of g of x as x approaches 3. Right? So you're just adding limit to each one of these things. The limit of x squared as x approaches 3, the limit of x as or the limit of 5 as x approaches 3. And with that one, it's just a y-intercept, so it's just going to stay as 5. Nothing is really changing with that one. If you have a limit and it calculates to something that's not over 0 divided by 0, that means that there's a vertical asymptote at that spot. So that means that's either going to go to negative infinity or infinity, and it can be like this, like that, or like that, or like that. If the limit as x approaches 0 or as x approaches a is equal to 0 over 0, then that means that you have to do some factoring or some rationalization, trig identity, or like L'Hopital, which we will talk about later. For example, let's start with this one right here. The limit of the square root of x plus 4 minus 3 over x minus 1 as x approaches 1. Third direct substitution gets us 0 over 0. And what I ended up doing is I just multiplied this whole thing by square root of x plus 4 plus 3, square root of x plus 4 plus 3. Right? Because that's just going to be 1 over 1. 2 over 2 is equal to 1, 3 over 3 is equal to 1. So any number over any number, if it's the same number, will be the same. And through that, I can multiply these two and I can rationalize until I eventually get the limit of 5 over the square root of f of 5x plus 4 plus 3 as x approaches 1. And that gets me 5, 6. And this is the same as the limit to this. So you can just write the limit of square root of 5x plus 4 minus 3 over x minus 1 is equal to 5 over 6. Speaking of trig identities, you might want to know these. This is, I'm pretty sure, the exact same thing that was in calculus or pre-calculus. Right, so these might seem a little bit familiar. If not, I really doubt you'll be seeing too much of this, but it's good to know just in case. These are the main ones you want to know, I'd say. Next, we have the squeeze theorem. If h of x is less than or equal to f of x, and f of x is less than or equal to g of x, and the limit of h of x and the limit of g of x as x approaches a are the same, then the limit of f of x is equal to L. And that's just a bunch of gobbledygook. That means that if these two equal the same point and f is in between those two, then it will equal the same exact point. It's the same basic idea as this one right here, except with 3 functions instead of 2. A function is continuous at a, or at x equals a, if, what the hell? A function is f of x is continuous at a when x equals a through the definition of continuity if the limit of f of x as x approaches a is equal to f of a. Oh, so let's say you have your slope of f of x, right? Or yeah, f of x, and f of x is equal to x. So here's my graph. Now as I approach 2, I start from the left, I get 2. And as I approach 2 from the right, I get 2. And once I input 2, I also get 2, which means that, okay, this is continuous at 2. Sometimes you'll have some discontinuities. These are the 3 main ones. You have an infinite discontinuity. This is your vertical asymptote. Your jump discontinuity, which is when you have 2 separate functions. Basically, this is what you'd find in piecewise. Same thing right here. And then you have a removable discontinuity. This is something that will kind of show up in piecewise. This isn't really something that you can get naturally, where, okay, something just pops out like that. Let's take a look at this question right here. If f of x, when x is bigger or less than 5, is equal to 12 over k to the power of 3 plus x, and f of x is equal to k squared minus x when x is larger than 5, and k is a constant, what value of k is f continuous on its domain? A, B, C, or D, and they have all these numbers. And the way I did this is I put it into Desmos, and you want to put these 2 equations into Desmos, and you want to put the equation x is equal to 5, or whatever the the intersection is. And you want to find a point where all 3 lines intersect, and if you do, that is the oh goodness, constant that makes the whole function continuous. As we talked about a little bit before, if the limit of f of x as x approaches a is equal to positive or negative infinity, then you have a vertical asymptote at x equals a. If the limit of f of x as x approaches positive or negative infinity is equal to some number, then there's a horizontal asymptote at y equals r, for example. Like if I had a function that looked like this, and there would be a horizontal asymptote at this y value, and we can say that this y value is equal to r. That's basically what horizontal asymptotes are. The intermediate value theorem, or IVT, if f of x is continuous over the closed interval a to b, and d is in between f of a and f of b, then there exists at least one point or one number c such that c is in interval a to b and f of c is equal to d. And that's basically a whole lot of yap, which can be, explained through this picture. I have a function right here. At a, the function equals 4, and at b, the function equals 8. If this is continuous, there must be some time, at least once, where, c is equal to, or x of c is equal to 5, right? At one point, this thing has to go through 5, is the idea. As I wrote right here, if f of x is continuous from a to b, there exists at least one point c in between a and b where f of c is equal to 5. And you write through IVT. That's one of the things that you need to know. It will ask you on questions like justify or say which theorem was being used. Yeah, and that's basically all of Unit 1. Let's go straight into Unit 2, derivatives. There's the definition of derivatives. There's 2 right here. For the derivative of f of x, you have the limit as x approaches a, which is f of x minus f of a. Can this focus, please? F of x minus f of a over x minus a. And another one right here, the limit of f of x plus h minus f of x over h as h approaches 0. Just find whichever one you like the most, and there is, a 50% chance that you'll know the right one when the time comes, but I don't really imagine that we'll see something like this on our tests. F prime of a is the slope of f of x at x equals a. And it is basically, it's like the average rate of change at just one point is the whole idea. Zoom out a little bit more. you're going to have to make sometimes tangent lines to a function at point A, and that's going to look like y minus f of a is equal to f prime of a parentheses x minus a. And this is basically just, your slope formula that you've seen over and over again. Y minus y1 is equal to slope times x minus x1, or xi, which is like your initial thing. If the limit of if the limit f prime of x is equal to x as, oh my gosh, if the limit of f prime of x as x approaches a, or a from the left, is the same as f prime of x as x approaches a from the right, and the function is differentiable, or because it's differentiable, that means that it's also continuous. So whenever it says, okay, da 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 is differentiable, what can you tell from this equation? If it ever says continuous, then you will know for a fact that that specific part of the question is true. Now let's talk about the derivative power rule. If you've done any AP calculus at all, this is probably going to look a little bit familiar. It is d over dx of x of n is going to be nx n minus 1. So the derivative of x squared is 2x, right? I'm moving that 2 over here, and I'm taking away 1 power. 3x, I'm taking away the power of 1, just making it 3. And the derivative of 5x to the power of 4, I'm moving that 4 over here. 5 times 4 is 20, taking away 1 exponent, x to the power of 3. Next, you will see a product rule. It is, if you're looking for f of x times g of x, it will be g of x times f prime of x plus g prime of x times f of x. And the best way to remember it is through this little Minecraft formula I have right here. The derivative of diamond block times emerald block is equal to diamond times emerald block plus emerald times diamond block. Quotient rule is a little bit similar. You have f of x over g of x, f prime of x times g of x minus f of x times g prime of x over gx squared. Or in the Minecraft terms, it would be the derivative of diamond block over emerald block would be emerald block times diamond minus diamond block times emerald over emerald squared, or emerald block squared. Now here are your derivative trig identities. You will need to know all of this. Without a doubt, this will show up on your FRQs, on your MCQs. So just like have these ingrained into your head. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. Tangent is secant squared. Cotangent is cosecant squared, but that's negative. And the derivative of e of x is equal to e of x, and the derivative of ln of x is equal to 1 over x. And one thing, there's a couple more right here. The derivative of secant x is equal to secant x times tangent x, and the derivative of cosecant x is equal to negative cosecant x times cotangent x. Now, one way that you can understand which part's negative and which part's not is if it starts with a c, there will be a negative, right? Cotangent, negative cosecant squared. Cosecant, negative cosecant times cotangent, right? That's how you know the difference between those two. All right, let's actually briefly talk about chain rule. Let's zoom out. Chain rule, in a function, there are inside and outside parts. Let's zoom in and take a look at that. There are inside and outside parts, and the chain rule formula is the derivative of the outside times inside times, derivative of the outside times inside times the derivative of the inside. So let's take a look at basically a similar one. Let's actually do some highlighting, in fact. So my outsides are going to be blue, and my insides are going to be green. So for this question right here, my insides are going to be 2x squared plus 8, and my outside is going to be 5. So I get rid of that 4, or I multiply the 5 by the outside, and I get 5, and I get rid of one exponent down. I move one exponent down, so I get 4. And the inside function is the same, and then I multiply it by the derivative of the inside function, which is 4x, right? 2x squared, multiply that 2 to the other side, go down one exponent, you get 4x. And then 8, if you ever have a constant in your derivative equations, it just disappears, right? So if I had 8, if I had 5, if I had, A, B, C, D, L, N, O, P, whatever it is, it's going to be 0. It's just going to be wiped from your equation unless it has an x attached to it, or a y, or some other important variable that you need to know that isn't constant. Sometimes there will be more than one inside. For example, for this equation, you have, what do you have? I think this isn't really one with more than one inside. This one looks exactly the same to me. Oh wait, here's the inside. So there's, first you're going to multiply by the most inside, or the most outside, which is this one, sine of 3, and we make that sine squared, get that 3 over there on the other side. That's all the outside most function. Then we're going to talk about the next, or the outside most function. Then we're going to go talk about the second, like the closest one next to that, which is the sine part. And that's going to get us cosine right here. And then we're going to talk about the third most inside function, which is this 3x to the power of 4 plus 7. The derivative of that is 12x. That's just how you go about that. It's actually not that bad. Here are some chain rule rules that you will have to know. The derivative of anything to the power of x is equal to anything to the power of x times the natural log of anything, as long as anything is the same number. The derivative of log of a times, the derivative of log ax is equal to 1 over x natural log of a. Okay, that is everything for very basic, just derivative rules. I will see you in the next video. Good luck.